Today I'll talk about the 2022 AMC 10A Problem 7. The least common multiple of a positive integer n and 118 is 180. And the greatest common divisor of n and 45 is 15. What is the sum of the digits of n? And there are 5 options as usual. So let's just start this problem. So firstly, we want to just write these sentences in the problem with mathematical language. So we use the LCM notation. The LCM of n and 18 is 180. We also use the GCD notation. The GCD of n and 45 is 15. So what do LCM and GCDs actually tell us? Well, so for the LCM, if you forgot, then you can just take a really simple example. For example, what is the LCM of, think of two similar numbers, like say 10 and 15. What is the LCM of this? So we can analyze it word by word. The least common multiple that these two numbers form. Well, that would be 30, because 10, so 10 is 2 times 5. And 15 is 3 times 5, so this is 2 to the power of 1 times 3 to the power of 1 and 5 to the power of 1. And 30 is 2 to the power of 1 times 3 to the power of 1 times 5 to the power of 1. So you take the greatest exponent of each prime number in the prime factorizations of the two number for the LCM. So what this tells us about the LCM of n and 18 is that we know that 18 is going to be we know that 18 is 2 times 3 squared, right? And we also know 180 is 2 squared times 3 squared times 5 to the power of 1. So these exponents are the greatest exponents within n and 18, like the prime factorization of n and 18. However, this here, 18 only has an exponent of 1 for the factor 2, meaning that n has to have an exponent of 2 for the factor 2. And we don't need a 3 for n because n already has a 3 here. 180 already has 3 squared and 18 already has 3 squared, but we need a 5 to the power of 1. So n is 2 squared times 5 to the power of 1 times possibly something else that we haven't discovered yet. Let's now look at the GCD condition. So GCD means, if we take the GCD of 10 and 15, it's 5, because 10 is 2 to the power of 1 times 5 to the power of 1. 15 is 3 to the power of 1 times 5 to the power of 1. And 5 is just 5 to the power of 1. So we just take the minimum exponent of each factor in the prime factorizations of the two numbers. So this means that for the GCD of n and 45, it's 15, and we know that 45, so 15 first of all is 3 to the power of 1 times 5 to the power of 1. 45 is 3 to the power of 2 times 5 to the power of 1. So since these are the minimum exponents of in the prime factors, the primes of n and 45, we know that n already has a 5 to the power of 1, but it needs a 3 to the power of 1 as well, so that the GCD of n and 45 can be 15. So this is the minimum for our number n. So if we add any more factors, that's unneeded and might cause a problem in the GCD and LCM functions, so that they do not meet the requirements of the question. So we just figure n out. In this case, n is 4 times 5 times 3, which is 60. So we want the sum of the digits of n, so that's just 6 plus 0, which is just 6.